not fit the use cases handled by relational database systems. An example is if the data your application is handling does not have a fixed schema or structure, then a lot of the NoSQL database categories can help you with that, like the document-based and the wide column-based databases. If your data also has specific structure that might suit it better, there might be some NoSQL databases that can help. For example, if you're planning to create a social networking site, you can create a network of friends using a graph database, then figure out who are friends of a particular person. This might be achievable with relational databases, but it will result in overwhelming number of computations. But for graph databases, it is easier to deal with this because it is exactly what it was meant to achieve. If your data has fixed structure, it is usually better to use the cloud services we previously mentioned, which are based on relational databases. NoSQL databases have also traditionally been employed because of their availability. This means that they have a built-in ability to replicate the data into multiple servers. Because of this, if one of the servers goes down, the other service can serve as its backup while it's still recovering. Nowadays, however, this has not been a huge issue when using relational databases because the cloud is able to replicate this kind of mechanism for Cloud SQL services as well. Next, let's look at how to actually create a NoSQL database. Welcome to this video on creating a NoSQL database on the cloud. So again, we're in the Azure platform and we'll create our NoSQL database here. Now, NoSQL databases are basically all the databases that do not fall under the umbrella of relational databases. So if they're not relational, they're usually categorized as NoSQL. So NoSQL began as like people not liking SQL, but then it evolved into not only SQL because a lot of NoSQL databases actually support SQL nowadays. So it's either they themselves support SQL or they already have like libraries that allow the conversion from SQL to their own language or protocol of communication, right? Because a lot of people in the data world know SQL, but a lot of them also can't code. There are a lot of people who can both use SQL and code, but for those who have focused on data for a long time, there are some of them that do not know like JavaScript, for example. So it's easier for them to use SQL and then just have it converted into something else that can be used in that particular database. But I digress. So there are a lot of different NoSQL databases, and so there are, for example, document based. We have graph databases. We have key value stores. We have wide column databases. So one of the most common of them is the document based, which is, for example, MongoDB. They're basically schemaless compared to relational databases that actually have a schema wherein you have the list of columns, for example, and then what are the data types of those columns. But document based doesn't have a schema, and so you can add whatever columns you want on the fly, right? And it still works. This works because each row in a document based is, instead of a row, it is a document from the name itself, right? A document is just an object, so you can just add anything in there. Like, it doesn't matter. Like, if you're building a JavaScript object, you're not really limited on what kind of objects you want to add. So unless it's class, right? But I'm saying objects, so you're not limited really. And then again, you can nest objects within objects. You can have arrays with objects and objects having arrays, and then so on and so forth. So yeah, so you don't really have like a limitation there with regards to the structure of your document. Which, in contrast with relational databases, it's a bit hard to pull off that kind of thing. Like, you have a column with nested values, right? It's a bit difficult to use. Other databases that have good support for that, like Postgres, for example, but still, it's not that common. Especially, it's difficult to pull data from that. And then, yeah, so moving on, right? On the Azure platform, the best way that we can create NoSQL databases is Cosmos DB. So Cosmos DB is the premium production grade NoSQL database store. So let's actually create one, so you see what I mean. Let's hit create, and we can search for Cosmos DB. Azure platform, the best way that we can create NoSQL databases is Cosmos DB. So Cosmos DB is the premium production grade NoSQL database store. So let's actually create one, so you see what I mean. Let's hit create, and we can search for Cosmos DB. It's usually gonna pop up in here, but again, one way that we can see this is just going to, as usual, the databases tab on the left side. We can select here Cosmos DB and hit create. Search your Cosmos DB. It's usually gonna pop up in here, but again, one way that we can see this is just going to, as usual, the databases tab on the left side. We can select here Cosmos DB and hit create. And then we are asked to select which API we want. So the recommended one is the core API, or the core SQL API, which is it's actually like what I said earlier, right? Usually can communicate nowadays with NoSQL databases using SQL, and this is and a lot of people prefer SQL when communicating with databases because it makes sense for them, for their mental model, right, of databases. So Cosmos DB created that sort of API for them. Now that's the recommended one, and you still get the benefits of a NoSQL databases, NoSQL databases, like high availability and fault tolerance, and then also like high speeds, like top class speeds. Like, for example, Cosmos API, Cosmos DB actually can reach speeds of less than latency speeds of like a single digit millisecond, so like less than 10 milliseconds of response time. So that's awesome. That's super awesome. This is because of how it is built underneath the implementation itself. Like consistency wise, we're using eventual consistency, meaning we don't have to wait for transactions to complete, but that can be adjusted, but we won't talk about that in this video. We'll discuss it in a later course, in the advanced course, right? So we have the core SQL database. We have the Cosmos DB API from MongoDB, meaning this is an API for document-based databases, right? So if you have some sort of MongoDB, then we can use that. So MongoDB is one of the most popular, if not the most popular, document-based NoSQL database. So there are other things that people like using as well, like Firebase on the Google side of things, and Google Cloud, right? People like using that as well. But before the whole Firebase Firestore thing, we had MongoDB, and it still is very popular, especially with Mongo Atlas, which is something that you can create in Azure as well. We have a Mongo Atlas offering as well in here. So like, your call, what do you want to use? So that's it for MongoDB, right? And then we have, so if you already have an existing MongoDB instance and you want to move to a more powerful production-grade document-based NoSQL database in the cloud, then you can use Cosmos DB API for MongoDB. So just flip the switch. So just migrate everything from your MongoDB into Cosmos DB, and just flip the switch, and then it would automatically work, right? So which is pretty awesome, right? So then next is we have Cassandra. Cassandra is a wide column based database. So if you're not familiar with it, it's basically like an a SQL database. It looks like a table, but you actually don't have also. It's also schema less ish. So you still do have because these tables are hierarchical. So the top columns are actually like fixed, but the columns are basically like very flexible. So it's like a relational table wherein you can just add whatever column you want. So it's sort of like that, and it shares the same style with Bigtable and other technologies like HBase, for example. But the implementation is a bit different. But I guess this is just an API, so I don't think the Cosmos DB implementation is exactly what Cassandra does, but it has the API for Cassandra. So if you have a Cassandra data store, you can just flip it to migrate to Cosmos DB and just point to this, and you're good. Right? And then we also have Azure Table. If you recall, in one of our videos in when we talked about storage, right? This is part of the storage account, Azure Table, and but I said that you have better options. You can actually choose a more production grade, a more powerful one by switching into the Azure SQL database, the fully managed service, or use Cosmos DB. So if you want a more powerful version of Azure Table, but you were already using Azure Table to begin with, and Azure Tables was again, I talked about this. It's closer to a key value store than an actual relational database. So you can just flip the switch and point to a Cosmos DB instance instead of the Azure Table, right? So it's better to use Cosmos DB than Azure Table these days, right? So next we have the Gremlin API, which is a graph database. So if you want to use something like if you want a use case where in something like a social media network, for example, and you have yourself, and then you have friends, and then you want to know who are the friends of your friends are, and then you want to like run an algorithm on the graph to get those, then that's something that you can do with a graph database. Well, it is definitely possible with normal databases as well, but it's way easier to do that. And graph databases are actually built for those kinds of use cases, so they're the best. They're your best bet for those kinds of things, right? So what will we be using? Okay, so again, I talked about MongoDB and how it is one of the most, if not the most popular document-based or NoSQL databases out there. So we'll use that. We'll hit create to create an API. So again, we can use Cosmos DB as a drop-in replacement for MongoDB. So just plop it in. Hit the switch, and we're good as long as you migrated everything to Cosmos DB. Right, so let's actually create this first.
We have more options in here versus the other options that we talked about before, especially for the relational ones. Um, let's call this intermediate cloud Cosmos. Let's call it that. And then, if I recall correctly, we don't have a Southeast Asia for Cosmos. Um, let's hit the East Asia instead. I think it's the closest one. There should be one in here. Okay, there we go. So two modes, right? So Cosmos DB is a fully managed service. Again, we don't like the Azure SQL database. We usually don't. We just define the server, but we don't really like manage the server ourselves, like as in like a VM itself. So we usually don't do that. We just interface with the database itself. But and that is the same with the Cosmos DB API, right? So we can select a provisioned one, which so if we do this, we can actually like um we can predict how much we're going to use. But in this case, we're just testing it out, so we'll use serverless. So there are less options there. But basically, if we don't use the database, we don't need to pay for it, right? And if we're using it, that's the only time we will actually pay for it. So there's a pay-per-use model. Okay, so sorry, I lost my train of thought there. There's a pay-per-use model. So if you don't use it, you don't pay. If you use it, you pay. But then, especially this is good for like for example startups. Right? If there's not a lot of people using your application, then there's no problem there. But the thing is, if your application grows, your user base grows, the costs balloon up. So it's sometimes helpful to use provision throughput, but it's your call. In our particular case, it doesn't matter. So it just makes it easier to just do this. So global distribution, we can the if you're using Cosmos DB, this is your like this definitely should be turned on, right? If it's a production grade setup, right? But in our particular case, we don't need to do that. But please, if you're doing like if you're really doing Cosmos DB for real in production, enable this, right? And then networking, not much to do here. But if you're communicate from within, which is the best case, right? If you're communicate from within your networks from within Azure, then it's best to just hit it with a private endpoint. In our particular case, it's a demo, so we with the private and the best case, right? If you're communicate from within your networks from within Azure, then it's best to just hit it with a private endpoint. In our particular case, it's a demo, so we with the private endpoint. They don't a Microsoft managed key. We won't use a customer managed key wherein we add it. We will set this as well, right?
Crazy in this thing we call love, and now that we've got it, we just can't give up. I'm reaching out for you, got me out here in the morning. I'm
Ano yung mga
overboard,
inlog? Hindi, pinaparecord
and
mo.
I need your love, only so crazy in this thing we call love, and now that we've got it, we just can't give up. I'm reaching out for you, got me out here in the morning. I'm
Ano yung mga
overboard,
inlog? Hindi, pinaparecord
and
mo.
I need your only love. I can't swim on my own, it's too much. Feels like I'm drowning without your love. So draw yourself out to me, my lifesaver, saver, oh, lifesaver, my lifesaver. Whoa. And I understood you when you say, oh, so crazy in this thing we call love. And now that we've got it, we just can't give up. I'm reaching out for you. Got me out here in the water.
Ano yung mga inlog? Hindi, pinaparecord
And
mo.
I need your love, only love. I can't swim on my own, it's too much. Feels like I'm drowning without your love. So draw yourself out to me, my lifesaver, saver, oh, lifesaver, my lifesaver. Whoa. And I understood you when you say, oh, so crazy in this thing we call love. And now that we've got it, we just can't give up. I'm reaching out for you. Got me out here in the water.
Ano yung mga inlog? Hindi, pinaparecord
And
mo.
I need your love, only
It's be- It's beginning to look a
Ng 16 anyos na pambato ng Pilipinas sa Asia Road Racing Championship sa Thailand. Namatay ang binata matapos sumemplang sa gitna ng laban. Nakatutok si Emil Sumangil.
Sa pagsakay sa pocket bike sa edad na 5 taong gulang, nagsimula ang pagkahilig sa motorsiklo ng International Motorbike Race Champion na si Amber Torres. Hindi nagtagal, pinasok na ni Amber ang mundo ng motorbike racing kung saan siya humakot ng mga parangal di lang dito sa Pilipinas, kundi pati sa ibang bansa. At nitong December 5, kumarera muli si Amber sa prestiyosong Asia Road Racing Championship sa Buriram, Thailand, kung saan siya ang kinatawan ng Pilipinas.
Nakabangat talaga. Excited ka. Excited, mas excited. Mas excited ka sa kaba.
Maganda raw ang naging simula ni Amber. Pero pagsapit ng ikatlong lap, naaksidente si Amber matapos siyang sumemplang. Naisugod pa siya sa ospital doon pero binawian din siya ng buhay kalaunan.
I'm so proud. Bilang mabuting anak at mabuting tao sa mga kaibigan, sa pamilya. Hindi ko maimagine.
You don't need
Ganun yung mangyayari na sa lahat ng hirap namin, biglang 3 araw wala na eh.
Nasawi sa edad na 16 anyos si Amber. Sa susunod na taon, higit sa 5 karera sa magkakaibang bansa sana ang lalahukan pa sana niya.
Kuya, alam mo na yung gusto ko sabihin sa'yo na always laging pray, manalo matalo. Nandito lang si Mami, ng mga kapatid mo, tanda mo, mahal na mahal ka namin.
Emil Sumangil, nakatutok 24 oras.
Bukod sa fresh seafood na mabibili sa palengke, kilala rin ang Rojas City sa mga bulad o daing na isda at sa uga o tuyo. Isa ito sa mga pangunahing industriya rito. Ang ugahan o ang pagawaan ng tuyo at daing na isda. Dito sa Barangay Cogon,
to do that right now. But it just really helps when you're in production. And here again, with same with the previous cases, right? We're using a Microsoft Managed Key. We won't. It's best to just hit it with a. You don't need to do that right now. But it just really helps when you're in production. And here again, with same with the previous cases, right? We're using a Microsoft Managed Key. We won't use a customer managed key wherein we add it ourselves. No, let's not do that. So let's move on. Let's create that. And validation success, and just wait for it to finish. Wait, I have not. I just hit review. Give it a sec. And again, we'll use Movie Magic and just fast forward this whole process because it might take a while. So let's be back when this has been finished. Alright, so now the Cosmos DB instance has been instantiated. So let's go to the resource. So now that we provisioned it, we can see it like moved directly to Quick Start, so we can see how we can connect to it if you're using .NET, if you're using Mongo. So this is just the sort of the basic way of doing that, but usually you'd use an ORM to connect to this. Same with everything else. We also have for MongoDB shell. So if you're using a Mac, then obviously it's not going to be that XC. You can use Docker as well, just a Docker Mongo container, Docker Mongo image that we can use if you want to connect directly. Just change Mongo.exe to Mongo sh. So it used to be Mongo, but I think it's already like deprecated now, so you can just use Mongosh, Mongo sh. So, and we also have Java, then Python and others. So you can just basically use these, so you can even connect using whatever you want, right? As long as it has something that can connect to via network, right? And send messages. So in our case, we won't do this, but we'll do something similar to connecting via the Mongo shell, which is actually creating Mongo shell later on. But first, to just get started with using the MongoDB API for Cosmos DB, then let's go to Data Explorer. So it's the simplest way to work with Cosmos DB directly here on the Azure portal, right? So let's actually see what's in here. You can have notebooks. If you're not familiar, notebooks are like pages where you can have you can combine documentation and code. So you can have cells wherein you have documentation in the form of Markdown. You can also have cells wherein you have code. In this particular case, you can run like Mongo code. So we won't use it, but it is a good way to work with data. Honestly, promise, just check it out. But in our case, we'll just create a database. There usually is a default one, but I think the default one is test. Just hit it. If you don't specify anything, usually it's just created as test, right? And the problem is it was created as. Give me a sec. Let's go back there. There's a problem with this. Delete this. I want this to be the lowercase test. There's the problem with this. Let's add. The problem is it was created as. Let's wait for that to finish. It was created as. Give me a sec. Let's go back there. There's a problem with this. Delete this. I want this to be the lowercase test. There's the problem with this browser. It automatically auto-completes and I can't turn it off, sadly. Let's wait for that to finish. Okay, so let's add a new database test. Let's make sure it doesn't. There we go. Okay, so it's small t. Okay, I think that's the default one, but if you don't specify anything, it will be created. So we didn't need to create it, but it's just what I like to do. So we can open up the test and see that there's really nothing there. And then so like tests are basically like the databases are just basically like relational databases. They contain multiple tables. Now tables in MongoDB are called collections. So collections have documents, much like tables have rows in relational databases. Now we can hit a collection, and we can create one. We'll call it like some names, I guess. That should be fine, right? And then create new, and then collection ID. the same thing. Sorry, it just should be like the existing one. And the collection ID is the name of the collection. Call it names. Starting with name of the collection. Call it names. Sharding so like SQL databases have support for sharding, but no SQL databases have better support for sharding or something similar. Some for some stores they call it partitioning. So right, so you can do that. Shard key, it would be the ID. That actually does make sense. And like SQL databases have support for sharding, but no SQL databases have better support for sharding or something similar. Some for some stores they call it partitioning. So right, so you can do that. Shard key, it would be the ID. That actually does make sense. And advanced, yeah, I mean that makes sense for now. We don't need to change that. I think that's the default one. It creates indices, but we can create one ourselves if we want in MongoDB, or in this case in Cosmos DB. But currently this makes sense, so let's create it. Let's create that new collection. But yeah, if you don't actually specify, if you don't actually create a collection, but you use a collection, there's by default you'll actually generate that collection even if you don't create it. Okay, but it's if I recall correctly, it's a setting that you can turn off, so that it doesn't create random tables if you like mistakenly use the wrong collection name. So, but by default, it just makes things easier. And like in relational databases, when you need to really like create table, create the name. In this case, you don't need to create a collection. You just need to use the collection, and if it doesn't exist, it will be created. Because again, no schemas, document-based databases, or no SQL databases in general. Right? So we now have a test, and we have the names collection. So we can actually try adding to that. So we can hit new query, right? Or just go to documents, and it will look at what documents we have, but we don't have documents here. So it will say load more, but there's nothing there. And then we can just move this to the, let's close it out. And then let's hit new document to actually add a document. And then we can just move this to the, let's close it out. Documents we have, but we don't have documents here. So it will say load more, but there's nothing there. And then we can just move this to the, let's close it out. And then let's hit new document to actually add a document. Now we get a default ID. So, and this is just because we're in here, right? We're in the Data Explorer, but by default, usually you actually get you actually are able to generate these things on the fly usually when you're using sort of ORM, right? But yeah, so ID, and then we'll add a name. So name. So let's actually save that, and then when we we can't really see that, but when we like expand that, we can actually see that. So ID, and then we'll add a name. So name. So let's actually save that, and then when we we can't really see that, but when we like expand that, we can actually see that in here. So when you open this up again, if you recall, it actually like adds an ID, right? So we can add an ID here, but we have the underscore ID, which is the auto generate, so we didn't actually need to add this. It was there, so let's add it there. So we can actually add another one, right? And this time we can ignore this completely because we get an auto generated ID. And then save that, and then let's wait for this to populate. And when we open this one, we can see that I didn't get an error, right? Usually in databases, in relational databases, if this is required, right, then it would tell you, hey, you didn't add any ID, so this is wrong. But in this particular case, it doesn't care. Like MongoDB or Cosmos DB, for that matter, doesn't care if you didn't add, because again, schemaless. You didn't add another normal ID, which is not the underscore ID. Just added a name, right? Because we get an auto generated ID. And then save that, and then let's wait for this to populate. And when we open this one, we can see that I didn't get an error, right? Usually in databases, in relational databases, if this is required, right, then it would tell you, hey, you didn't add any ID, So this is wrong. In this particular case, it doesn't care. Like MongoDB or Cosmos DB, for that matter, doesn't care if it didn't add, because again, schemaless. It didn't add another normal ID, which is not the underscore ID, just added the name, and that's perfectly fine. It doesn't matter. So if you have schema evolution happening in your data, in your database, in your collection, it doesn't matter. It doesn't break anything, right? Which is actually great. But then all this also part of it wherein you have no idea that a new column was added, right? Or somebody made a mistake with the column. So that's when, you know, these schema versus schemaless paradigms usually have their own pros and cons. So just depends on what use case you're using. Right. So honestly, for me, I like the type safety, for example, and that the schemas afford. But I also want things to be flexible to some extent, right? But there are ways to do that kind of schema evolution, right? Apart from just using, even if you're just using SQL databases. But you know, that's a different topic for a different time. Just so you know, it is possible, right? Just search for schema evolution, and then yeah. So we use the data explorer to add and look at the values that we created. So now, what if we want to connect to using our application? We saw that in the quick start, right? But we also can use connection strings, right? So here are our connection strings. These are the details that we have, and if we have something that uses a connection string, then we can just plug in a connection string, and then there we go. We have access immediately. But start from just using, even if you're just using SQL databases. But you know, that's a different topic for a different time. Just so you know, it is possible, right? Just search for schema evolution, and then yeah. So we use the data explorer to add and look at the values that we created. So now, what if we want to connect to using our application? We saw that in the quick start, right? But we also can use connection strings, right? So here are our connection strings. These are the details that we have, and if we have something that uses a connection string, then we can just plug in a connection string, and then there we go. We have access immediately. Well, the more secure way of doing this would be using AD, right? Using managed identities, which again we won't talk about here, but we'll talk in the advanced course. But again, you can use connection strings. So what's an example of an external system that you can use to connect here? Well, if you're using MongoDB, in this case, we're using the MongoDB API, we can use Mongo Compass. So we have Mongo Compass here. So Mongo Compass is basically MongoDB is like Premier UI to some extent, right? So this allows us this has a lot of awesome features, right? You can monitor your queries, you can monitor the performance of your queries, you can monitor you can actually look at you can have this explain your query, right? So it just affords a lot of things, a lot of awesome things in here. So let's look at that next. Right, so let's make this work, shall we? So to make this MongoDB Compass work, we need, as this is, a connection string. And where do we see that? Well, we saw that earlier. So we have our primary connection string in here, and secondary one we can pick. one of them, and then just go here and paste that in, and then hit connect. Just wait for it to finish. And there we go. So again, we have that DB test, right? If you recall, one of them, and then hit connect. Just wait for it to finish. And there we go. So again, we have that DB test, right? If you recall. Now, so we can look at what's inside that. Names, again, same thing. And we can see the actual details, right? And we can add more data. So like we can insert document and say you need to specify that. Again, that's a given. So we can add like name, for example, and then insert, and then we have that name in there. Perfect. So there are a bunch of things that we can see in here as well. We have aggregations, schema, but again, it's flexible. So you can also have like these explains. Yeah, there's really nothing in here yet, but yeah, let's actually now we tried actually adding one via the UI. There's actually another way that we can add data in here, and that's by using Mongo sh, like, however you want to use it. So in here you can see that we have the DB and we have the test collection here, actually the test DB. We can actually use something else. You can use, for example, a main. So we're now using the main database, and again, if it doesn't exist, it will get created. So same thing with collections. Again, I talked about that. If it doesn't exist, it will be created. So now we're in our database main, so we can hit you can just consult the MongoDB documentation for these kinds of details. But for example, we can insert things into a collection. We can insert documents into a collection. So we can add specify a collection here, db dot and a collection name, right? db dot, in this case we'll call it shows, I guess, and then insert one. Now if we do this, right, this will add one entry to the shows collection, which doesn't exist yet, like the main collection. So we can add the title of the show, for example, and then I could say called Tensora 2022. I think it's 2022, and then we can add genres as well. So we can add action, fantasy, and then comedy, I guess. There's isekai as well. Then Celic died. So genre, anything else? I think that's it. So now if you look at this, right, we have the title, the attribute title, or like if in relational terms it's like a column, right, and then we have a string here, and then in genre we have a list, right? We have something similar to an object instead of like the primitive data types like a string, float, or integer, right? So those kinds of things. So we have something like this here, and we talked about NoSQL databases being able to support nested, especially like document-based databases. They can support nested objects within their documents, right? So if we actually hit this, it will be created. And acknowledge true is useful for when because we're using like in Cosmos DB, especially for eventual consistency. And then we can refresh this to see that we have a new database, which is main. Again, we did not hit anything like create database in here, right? We just said we want to use a main database, and it was created. And then we did not specify to create a new collection. We just used the collection shows, and it was created. Again, there probably is setting here which allows us to like not immediately create one, but by default it is automatically created when we need it, which is very convenient if you're just starting out. So in here you can see that we have the title, which is a string, and then we have the genre, which is an array of items of these genres, right? Which is awesome. So so you can actually just search for things like if this movie, like filter all movies or like shows that have this particular genre in the list of genres, right? So we can add more things into it, and then we can even add it here if we want, right? Insert document. But we can also look at the values in here, like db dot just specify the name of the collection again, and then find, and then you can add more things in there as well, things into it. and then we can even add it here if you want, right? Insert document, but we can also look at the values in here, like db dot just specify the name of the collection again, and then find, and then you can add more things in there as well, like you can add like add it here if you want, right? Insert document, but we can also look at the values in here, like db dot just specify the name of the collection again, and then find, and then you can add more things in there as well, like you can add like filters in there if you want, like specify that the title is of a particular like movie title here, for example, but that doesn't exist. Nothing, there are no results. But nevertheless, that's how you do it, right? You can create using the Mongo Compass. You can specify host, right? And then specify the connection string to actually connect to it, and then add data, and then read data from it, right? So that's it. That's how you use Mongo Compass to read Cosmos DB instance, which has the Mongo API. So in the next video, we'll look at actual data warehouses in the cloud. So see you in the next video. Mongo Compass to read Cosmos DB instance, which has the Mongo API. So in the next video, we'll look at actual data warehouses in the cloud. So see you in the next video.
Data warehouses are cloud data services where we store and process massive amounts of data from different sources. These kinds of data stores are used for things like heavy computations, especially for analyses. We use them to store data from a wide variety of sources. Then we do computations on the stored data and store them again in different tables. Then analytics software like Power BI and Tableau can now read from these tables and display them as dashboards so the business stakeholders can make informed decisions from the actionable insights. An example of this is Azure Synapse Analytics, which is a newer and more powerful version of the former Azure Data Warehouse. Next, let's talk about when to use data warehouses. The previous kinds of data stores we've talked about usually handle data that is transactional, data that is usually written and read, with some computations here and there. But for dealing with massive amounts of data and doing computations on them, transactional database services aren't enough because that's not what they were made to do. If you just want to process transactional data, these types of services may not be for you. But typically, these services request very powerful machines for heavy and complex processing. This means that every time it runs a process, it takes up a lot of resources, which increases the cost. Hence, this is not something you would want to do with your transactional data. But if heavy computations and data analytics are your use cases, then this is your best choice as a data storage service. Next, let's look at how to create a data warehouse. Welcome to this video on data warehousing in the cloud. So data warehousing allows us to do analytics and save our files historical data, right? So we can process them in a massively parallel manner. So we do that in data warehouses because we don't want to do that in our operational databases because it will add some load and ruin the performance of our applications that are using databases, right? So we want to keep them separate, keep the storage separate, keep the compute separate, and we want to keep them as cheap as possible as well. So they're only up when they are needed and they're stopped when they're not in use, and then the storage has to be as cheap as possible, right? So data warehouses accommodate those kinds of use cases. So for every cloud platform there is one, and there are also a lot of like external ones out there as well. So for Azure, what we want to use is Azure Synapse Analytics, which was the former Azure SQL Data Warehouse. So Synapse Analytics, search that. And then we see here that it says that it's a limitless analytics service that brings together data integration, enterprise data warehousing, and big data analytics. So it really just combines those three. So previously it didn't have, for example, data integration. It had, but right now it actually uses a more robust system, which is still a separate service, but it's also now part of the original, which is now part of Synapse Analytics as well. But the original service is still up there somewhere, and it's still being used by other people who don't want to use Synapse but want to use data integration. Now let's create our Synapse workspace first before we can actually see what it can do. So you might not be able to imagine that, but just me saying things. Intercloud RG, let's call it that, or just Intercloud RG. Let's not add any of those dashes anymore. So I've had like problems requesting them or provisioning them because of some problems with the names. Intercloud Synapse, or just Intercloud RG. Let's not add any of those dashes anymore. So I've had like problems requesting them or provisioning them because of some problems with the names. Intercloud Synapse, let's call it that. The account name, the ADLS. It's fine, right? And then new Intercloud Synapse FS. So let's call it that. There we go. So last thing we need to do, I think, is set up security and oops, should admin and add the password. Is that correct? I think that's correct. We can't enable that anymore. Networking. I think this is okay as well. So we can review and create and hit create. So that for a bit. There we go. So yeah, this will take a while. So let's just wait for it to actually finish deploying. Let's just wait for the deployment to begin. There we go. So let's fast forward this. Alright, so now we've created our Synapse Analytics workspace. It took me a while because it kept failing because I don't have enough resources. Now I do. So, but now we have it here. So our use case would be to analyze, actually just to pull the data together from different files, right? Which contain data on vaccine adverse effects. Now I'm not an anti-vaxxer, but during the early stage of vaccine creation, there usually are problems with developing the vaccine, right? So this data is about that data, like what symptoms people got when they were administered that particular vaccine and whatnot. It's not just also COVID, but a lot of other vaccines as well. Nevertheless, let's look at the left side. So we have home, data, develop, integrate, monitor, and manage. So I actually go through these things one at a time, like in order except for manage, right? So first we will get our data. We get our data sorted out. We get our data, and then we develop pipeline to process it, right? A data flow to process it, and then to actually use the data flow, we add it to our pipeline. We create a pipeline which will trigger that data flow. Okay, then finally, once that's running, we will monitor the progress of said run in monitor, right? So okay, let's get on it, shall we? Because this will be long. So let's go to data. So first thing that we need to do is actually look at this. So we can create a workspace in here, but in our particular case, we don't know the schema beforehand. So if you are actually like, do you know the schema beforehand, right? If you have a specific schema in mind, you can actually create a resource like a SQL database or a Lake database, and then write to that. In our particular case, we don't know the particular schema. So if we don't know the schema, right, we can just do what we call schema on read, which is basically you read the data, then you enforce the schema afterwards, not the other way around, right? So we don't know the schema yet, so we will just dump the file and then read the file and then just apply the schema once we read the file, right? So for that particular case, right, we're going to use data lake storage Gen2 EDLS for both input and output, okay, for our data flow. So we can just literally just create one ourselves as well in here easily. We'll connect to an external data source, but it's already here. So we already have one created as we created our so it's also created by default when we create Azure Synapse instance, right? We saw that earlier. So it has been created here, so we don't need to create one anymore. Just use this one. I don't want to create another one. It's just a waste of space and money. So that's our data. So before we actually proceed, one thing that you probably would want to know is that for every step that you do, ideally you should validate and publish it. So we have validate all and publish all. We can hit publish all and it will automatically also like hit validate all, but if you want to like validate it without publishing, you can hit validate all. The good thing here is this is actually something that you need to do, because sometimes you don't get previews of your data when you don't publish it. So if you need to use your data or a particular step in your data flow somewhere and you don't publish it yet, sometimes you don't get the results that you need, so you need to keep publishing it. So for example, you don't get to see the schema because you haven't published it yet. So yeah, you need to deal with those things. So let's actually add our data first before we proceed. We can add our data later, but I want to like do it here that you need of your data when you don't publish it. So if we actually proceed, one thing that you external data source, but it's already here. So we already have one created as we created our you don't get previews preview. Probably would want to know is that for every step that you do, ideally create Azure Synapse instance, right? Like hit validate. Actually add our data first before we proceed, our data flow. So we can just literally just create one ourselves as well in here easily. We'll connect to an external data source, but it's already here. So we already want to create another one. It's just a waste of space and money. So the button here. So for example, so let's actually add our data first before we proceed. We can add our data later, but I want to like do it here and then publish it while we're here in the data stage, right? So this is my FS, right? My file store, and I have a couple of options here. I can create a new folder, I can create, and then I can directly upload it. In my case, I want to just directly upload it, so I'm gonna hit upload and click on the upload button here, and then I wanna go to the 2021 data. So I think 2020 has more data, right? But I'll pick the 2021 data, and this is already like 616 MB, so this will take a while to upload. So I will hit that, open, and I will upload. So I will just keep it as is here for now, and then we'll wait for this to finish. Okay. Upload. So I will just keep it as is here for now, and then we'll wait for this to finish. Okay, so see you in a bit. So now we've uploaded the data that we needed in here. So it's 616 MB if I recall correctly. So let's proceed to develop. So develop, we have a bunch of different options to finish. Okay, so see you in a bit. Create new SQL script. So now we've uploaded the data that we needed in here. So it's 616 MB if I recall correctly. So let's proceed to develop. So develop, we have a bunch of different options that we can actually do here. We can create new SQL scripts. We can create a new notebook, which is similar to like Databricks or a Jupyter notebook, a Cold notebook, or a Zeppelin notebook, something like that, right? Or data flow, which is actually what we're interested in, but we'll create that in here. So the things that we can see here, we can actually see here as well in this plus button in develop. So we'll create a data flow. So data flow is just a visual way of creating like
source and then the processing that happens in between that in here. So the things that we can see here, we can actually see here as well in this plus button in develop. So we'll create data flow. So data flow is just a visual way of creating like source and then the processing that happens in between and then the destination, right? So this is just basically moving data through different processes until it gets to a destination. So what we need here is to actually change this into there's data flow. So integration. So we'll add a source. Actually, before that, right? Let's create integration datasets. So integration datasets are actually let's create integration datasets. So integration datasets are actually our data sources and data sinks, right? Where our data comes from and where our data rests at the end. So if you're familiar with Azure Data Factory, this basically looks like it. So we'll search for what we already have, which is data lake storage, right? So hit continue, and we will read delimited text. It comes from and where our data rests at the end. So if you're familiar with Azure Data Factory, this basically looks like it. So we'll search for what we already have, which is data lake storage. Right, so hit continue, and we will read delimited text file, CSV, a comma delimited file. So let's hit that. So we'll call this, let's call this data, because we have data, vax, and then symptoms, right? So let's call it that. So we can select our default ADLS instance, right? Then select rows header, and we can search for the particular file that we want. So where's data, and this is what we want, right? Then select rows header, and we can search for the particular file that we want. So we'll call this, let's call this, we have to check this, have data, can select our anything else. We have to check this because we want that particular schema. Search for the particular file that we want. So where's data, and this is what we want. All right. So anything else? We have to check this because we want that particular schema. Okay. So we create that data. This looks good. So let's look at the schema, right? So we have the schema correctly. We have the correct schema. Instead of having just column 1, column 2, if we have the first row unchecked, and then we'll create another one. Actually, let's delete the data flow first, so we don't use it yet for now. Let's create another integration dataset. Schema, right? So we have the schema correctly. We have the correct schema. Instead of having just column 1, column 2, if we have the first row unchecked, and then we'll create another one. Actually, let's delete the data flow first, so we don't use it yet for now. let's create another integration data set. So same thing for data lake. Always pick Gen 2. We'll call this one we have data and then vax. We'll just call this vax. Then we have the linked service, which is the default um, data lake. And then we'll use vax. There we go. And first row is header as always, and then OK. Wait for that to finish, and then check schema. Okay, schema checks out. And then finally, the last one, we will select the same thing, data lake, Gen 2. The limited text, we'll call this symptoms. The linked service is still the same. First row is header. Select the data, symptoms. This looks okay. I'm gonna hit OK. Let's look at the schema. See, okay, so this checks out. Okay, so what else can we do? So let's publish this, right? So again, we need to publish this so we can like see the schema of it when we create the data flow. Just wait for that to finish. It should be quick. So while that's happening, let's create our data flow. We won't use the data yet, but let's create the flow for now. Let's wait for this to get published. Published, perfect. So now we're add. Select the same thing, data lake, Gen 2. This, right? So see, but let's create the flow for now. And we need to publish this so we can like. What else can we do? So let's publish this, right? So again, we need and like see the scheme of it when we create the data flow. Just wait for that to finish. It should be quick. So while that's happening, let's create our data flow. We won't use the data yet, but let's create the flow for now. Let's wait for this to get published. Published, perfect. So now we're adding our sources. Let's call this again Bears data flow. Then add source. So when we click and add a source, you notice that we can actually add more sources, and we will, right? So for this one, we'll call it vax, and then search for dataset. We already have them here. Sorry, let's call this data first, because that has the most data. So we can select a couple of things in here as well. Skip a bunch of data if you want, but we would like to go to these other things as well. Currently we don't have any like anything to do in this. We can select a couple of things in here as well. Skip a bunch of data if you want, but we would like to go to these other things as well. Currently we don't have any like anything to do in this particular case. One interesting thing that you can do here is that, for example, after doing a processing, right, you can actually like delete sources, right? If that's something that you want. It's just something that I keep doing sometimes, so that when I see this in a visual manner, it's just really cool. Instead of doing that in code, it's pretty nice. So you can actually like modify the columns if you want, right? In this particular case, I don't really care. So optimizing, we don't really use this unless we want to save it into a single file, but we're still in the source, right? So we don't need to select single partition, inspect, and then data preview. So I think this will be useful. I think data preview will be useful, but in order to enable this, actually, we need to enable debugging, which is this data flow debug in here. So to actually do that, this works fine. So let's get that ready for now. Nevertheless, let's continue, right? So the data preview anyway allows us to see the data at particular stages, right? So we don't have to run the whole flow to see the end result of the data. We can actually preview the data at particular stages, right? Nevertheless, let's move on and create the other sources. So next is the data source vax. Let's pull that. We'll call this vax, and I don't think we changed anything as well. So let's roll with it. Then we have other sources. So next is the data source vax. Let's pull that. We'll call this vax, and I don't think we changed anything as well. So let's roll with it. Then we have symptoms. And same thing, we select the symptoms dataset, and we're good. Right, so let's see if it's still running. Okay, so this is still processing. That's fine. So what do we need actually? So this data, if you look at it, right, if you inspect it, we have various ID, receive date. So this is just a bunch of data about the particular instance that
Sinain niya. Sa may ako.
The vaccine was applied. But it's not a complete set of data, so we don't have the details about the vaccine itself, which is in the VAX table, and we don't have the complete list of symptoms, which is in the symptoms table, symptoms data set. So what we want to do is actually combine all these tables together. Okay, so that's exactly what we will do. So again, I told you that for data flows we have sources, we have the transformations, and we have the sinks, which is where the data ends up. So if we click the plus button in here, we actually have a bunch of things that we can do. So we have, like, we can join multiple outputs. This is something we will do, but not exactly. We will use the lookup, but we'll also have a bunch of other options in here. Like we can create a new column or modify a column using the derived column. Just select columns that we need, which we'll actually use later, and then aggregate stuff as well, like create a result from a couple of rows of data, for example. And then create surrogate keys is actually useful for like creating keys if they don't have any, like especially if each row is actually unique but they don't have a key. And then a bunch of other things, right? Pivoting, unpivoting, windows, window functions, ranking, which is like also like windowing as well. And then external call, which is pretty new actually. You can call like external APIs, and then get the result of that call. Always for these operations, there's always a result. Okay, so there's always a result. So a bunch of other things here as well. Stringify, flatten, filtering, sorting, auto row, assert, and then we have a new one with Flowlet, which is actually a Flowlet is actually like a mini reusable data flow. So if you have a data flow that you keep reusing, then you can data flow with that out of it, and then you can keep using that somewhere, so everywhere, right, if you need to. In a particular case, we want a lookup. So a join is just a normal join. If you're familiar with SQL, it's just a join. So you can pick if it's an outer, if it's an inner join, left outer, right outer. You can even do a cross join in here. But what we actually want is the data has more data, right, than the others. So if we use join and we select, if we select an inner join, for example, then you would lose the data, a lot of the data in here in data, because it might not be available in vaccine symptoms. I don't know. I just like to err in the side of caution, right? So we do have an option of selecting a full outer, right, or a left outer, or a cross, which is insane, but probably left outer, right? But if it's a left outer, we already have one that fits the bill completely. We have the lookup. Lookup is just basically left outer, which is more semantically correct, I think, if you think about it. So it makes sense the most. So if you're going to this and you have no idea, you have no absolutely idea what a left outer join is, you can think of it as like looking up the values of something in another table and then completing the whole data, right? So it makes more sense. So it's basically just a left outer, but there are more details to it, but it's just basically left outer. So we can call this data vax. So we're looking up, so we're using the data as the primary data stream and then looking up the data from vax, right? And we can match multiple rows if we want, right? And yes, we will do that definitely. From vax data, basically just a left of it that makes sense. Lookup is just basically an option of selecting a full outer, right, or a left outer. Lookup is just a side of caution, right? So we do have an option of selecting a full outer, right, or a left outer, or a cross, which is insane, but probably left outer, right? But if it's a left outer, we already have one that fits the bill completely. We have the lookup. Lookup is just basically left outer, which is more semantically correct, I think, if you think about it. So it makes sense the most. So if you're going to this and you have no idea, you have no absolutely idea what a left outer join is, you can think of it as like looking up the values of something in another table and then completing the whole data, right? So it makes more sense. So it's basically just a left outer, but there are more details to it, but it's just basically left outer. So we can call this data vax. So we're looking up, so we're using the data as the primary data stream and then looking up the data from vax, right? And we can match multiple rows if we want, right? And yes, we will do that definitely. And then we have the conditions, right? When do we match? So we want VARS ID and VARS ID as well. And that's it, right? So I think the flow debug is done, so we can actually go to data preview and refresh this and see what it looks like when it's been created. Just wait for it for a bit. Just taking a while, huh? Oh yeah, because we have a lot of data because we're using data 616 MB, so it's a lot. So I'm not sure if we're even able to preview this, but I think we should move on and let's go back to this when this is done. So let's proceed. So okay, so that's actually done, right? So we can see that Vax has the detail for the vaccine. So let's actually look at the very end, right? So we can see the details now. So what vaccine it was, what was the site wrote, the vaccine lot and dose. So we can see that, for example, this one is Moderna. This particular instance is a Moderna one. This was a Pfizer one. So yeah, so let's continue doing that. So this time another lookup.
right? So from DataVax, it's called DataVax symptom. So combining all those three now, and then DataVax, and then looking up symptoms, right? And then match multiple rows, and then same thing, right? So in this case, we'll pick this as well again, and then there's data again, there's ID. So there's ID in particular instance case, right? So again, I think the data preview is enough. So let's move on to selecting, right? Because we're going to select, right? Because select dedupe, select useful. Let's just I guess let's just stick with that, I guess. Select dedupe, select useful. Let's just select useful. Let's just stick with that, I guess. So what we're using here is this for this actually skip duplicate input columns, skip duplicate output columns. Because if you recall, right, if you go back to here, we actually have multiple VARS ID columns, right? Because each of the table has a VARS ID which we're using for the lookup actually, right? So it's being created as data at VARS ID and like VAX at VARS ID, and then we have like symptom at VARS ID. But the thing is, because of that, right? There are actually like multiple VARS IDs, which is pretty useless. So what we want is just select the deduplicate it, right? If it's not being used, then don't use it. So just reduce them into one column because it's all the same anyway, right? So this is what we're using to select for, which is great. So and also if it's not something that you're using it for, not deduplicating, but deduplicating is very useful, you can actually just select, really just specify in here which columns you want. But in this particular case, we want everything except for the duplicate ones, so we're good. So next we will create a sink. So for a sink, right, we'll use the same thing, right? Our workspace DB. I will select the default.
Most especially yung mga senators nyo on how they deceive you about things. Okay? Let's talk about subsidy and budget according.
The default database, and say like destination, we'll call this destination, and then we'll create a table. So the table doesn't need to exist. So we just call the table that, and then we'll look at the couple of things in here. So in here I want to recreate the table,
So if you're doing this again, it will recreate the table, right? So what else is in there? This works already, right? We don't need single partition because it will create a single file that is horrible. It's really huge. And then finally the preview. We don't need to preview that, so let's actually just publish this first. And then after publishing this, we will create a pipeline for that. But first, publish, and then we'll see you in a bit. Alright, so we've actually finished publishing the changes to our data flow. So what is the next thing that we will do? So we will need to fire this, right? So a data flow needs to be inside a pipeline in order for us to fire it, right? So a pipeline is basically a bunch of different. We've actually finished publishing the changes to our data flow. So what is the next thing that we will do? So we will need to fire this, right? So a data flow needs to be inside a pipeline in order for us to fire it, right? So pipeline is basically a bunch of different actions, right? A bunch of different activities that can be connected to each other. Now, what the difference is in pipelines, right? Data doesn't flow really through the pipelines. It's just what it does is just after one happens, the next happens, but the data doesn't really flow. So for data flowing between activities, you should use a data flow. That's exactly what it's for, right? So in this particular case, we'll call this a VARS pipeline. So one such activity is actually data flows. So you can search here on the left side, we have data flow. We can drag that in there. So it's a drag and drop interface, and we can rename this VARS. So one such activity is actually data flows. So you can search here on the left side, we have data flow. We can drag that in there. So it's a drag and drop interface, and we can rename this VARS data flow, if that's possible. Can we have spaces in there? Good, we can. Right, and then so the important things in here is in settings, we need to select the data flow, right? And then the other things in here are the usual stuff. You need to select the compute type, right? And then like core count. So these are the things that you need to check out if you want to optimize for the performance of your pipelines. But for this particular case, we don't care. It's just a small amount of data anyway. So what we next need to do is actually run this. But before that, right, it's not something that we'll actually do here, but I'll just show you something nice as well. So what if you want to do something if this succeeds, if data flow succeeds, right? What if you want an action to happen, or what if you want some action to happen if it fails, right? So you can use this as well, like what we have in data flow, but instead of like in data flow, wherein the data flows through the whole pipeline, in here we just specify what happens when a particular activity succeeds. So for example, we want to send a message, right? If this data flow succeeds, then for example, we can do an Azure function, right? To for example, send an email, like send email or send message or something, right? So you'll connect this here, right? So what if this fails instead, right? So what if you want to send like notifications, right? If this fails, then we can do something similar as well, right? And we'll call this send notifs or send error notifs, And then what we'll do is in here click this plus and then say failure, and then drag this red one and connect. Or send error notifs. And then what we'll do is in here click this plus and then say failure, and then send notifs or send error notifs. And then what we'll do is in here click this plus and then say failure. What if you want to send like notifications, right? If this fails, then we can do something similar as well, right? We'll call this send notifs. I'm connected here. Now then we can just fill this in with, and then what we'll do is in here click this plus and then say failure, and then drag this red one and connect it here. Now then we can just fill this in with the Azure function. We can create an Azure function, deploy it, and then connect it to these activities that we have here. So if when the data flow completes, right, if it succeeds, then it goes to send the email. If it fails, then it goes to send the error notice. Just things that you might find interesting while you're building pipelines, but we're not necessarily going to do that here because it will take a while to build. So here we only have one data flow. And also, one more thing, right? One of the more popular as well ways to work with moving data around the integrations, right, is copy data. So this actually has integration with more services, and it also should just move data from somewhere to somewhere. But if you want some transformations, the data flow is the best way to go. Yeah. So let's actually run this now. So to run a pipeline, we need to add a trigger. So there are multiple types of triggers, but this what we're going to use now is the manual trigger, which is triggering right now, right? So we can hit trigger now, or we can create triggers that can be used by other pipelines as well, something like scheduled triggers or like recurring triggers of particular pipelines, which are very useful in real life scenarios. But in this particular case, we just want to trigger it now. So hit that. Pipeline not found, please publish first. Okay, we need to publish this first. Wait for it for a bit. This won't take long because there's only one. Let's just wait for it to finish. Alright, successfully published. So we will hit add trigger again, trigger now. Okay. Okay, so let's wait for this to finish. But let's look at so after our integration, right, again I mentioned that we will go from data to develop to integrate and then to monitor. So this is where we actually look at what's happening in our pipelines, right? So in this particular case, this one's running, so we can look at what's inside of the running data flow. So we can go over here at the bottom where we have this like this eyeglasses icon. We click that, we can see the steps, and we can zoom in and see, then to monitor. So this is where we actually look at what's happening in our pipelines, right? So in this particular case, this one's running, so we can look at what's inside of the running data flow. So we can go over here the bottom where we have this like this eyeglasses icon. We click that, we can see the steps, and we can zoom in and see monitor. So this is where we actually look at inside. We click that, we can see the steps, and we can zoom in and see which step is being done right now. But right now there's nothing being done because if you look at this, it's still acquiring compute. Okay, but once this is finished, we'll be able to see different details about it. So we can look at, like, for example, data, how many were processed in here as well, right? So we'll be able to see for the whole thing, like how long's the process time, what's the highest process time of a particular step, how many rows were written, etc. Right? So this is already running now. It's still acquiring compute, which is creating the machines needed to run the actual data flow, and then after that it will start executing. But yeah, let's wait for that for a bit. Data. The flow is completed, right? The whole pipeline is completed, and we can see that the cluster startup time took 2 minutes and 20 seconds, but the whole processing time of the whole data flow is 40 seconds. It's not that bad, right? We could have made a bunch of optimizations here and there, and given that it's like 838,000 rows, then that makes sense, right? And the highest processing time of a step is 27 seconds. Not that bad, not that bad, right? So let's see the actual output of this, right? So we can see that the data is now, if we go into, so let's see the actual output of this, right? So we can see that the data is now, if we go into Azure Data Lake Gen 2, Intercloud, we see that we have a Synapse directory here. We can go there, workspaces, Intercloud, Synapse directory here. We see that we have a Synapse directory here. We can go there, workspaces, Intercloud, we have this, right? So we can see that the data is now, if we go into cloud to Azure Data, is 27 seconds. Not that bad, not that bad, right? 2 minutes and 20 seconds executing. But yeah, let's, so this is now cluster startup. You see that the data that we have a Synapse directory, Gen 2, that we have a Synapse directory here, there, workspaces, Intercloud, warehouse, and we have our data here. So this is our data warehouse where we are pushing our data here. So the data is in Parquet, compressed with Snappy. So we're retaining, we're compacting the data and putting it in a column store, right? In a column oriented store like Parquet, right? So that makes it that makes the storage a bit, a bit more efficient, right? So we don't spend a lot of space, especially since we pay by, even if it's cheap, right? It still is a lot. So we need to like make this a bit compressed. So if you actually look at this, right, we had a lot of data that was like 616 MB, but if you see this, it's probably not going to be like, oh yeah, it does have a couple of pages, but it is compressing it a bit, so it's pretty good. All right, so that's it. We were able to use Synapse Analytics to get data from somewhere. So we uploaded data, right, and we processed it using data flows, and then we saved it into our data warehouse. So there we go. So if you want to use a data warehouse and process your data in in a very powerful fashion, right? You can do like massively parallel processing of your data and like analyze them to create actionable insights for your business, right? So if you want a data warehouse in Azure, this is one option, Synapse Analytics. If and there are for other clouds other options as well. So yeah, just take your pick.
So crazy in this thing we call love. And now that we've got it, we just can't give up. I'm reaching out for you. Got me out here in the water.
Huwag ka may index mo.
Ano yung mga inlog? Hindi, pinaparecord
And
yun.
I need your love, only love. I can't speak. So crazy in this thing we call love. And now that we've got it, we just can't give up. I'm reaching out for you. Got me out here in the water.
Huwag ka may index mo.
Ano yung mga inlog? Hindi, pinaparecord
And
yun.
I need your love, only love. I can't swim on my own, it's too much. Feels like I'm drowning without your love. So draw yourself out to me, my lifesaver, saver, oh, lifesaver, my lifesaver. Whoa. And I understood you when you say. So crazy in this thing we call love. And now that we've got it, we just can't give up. I'm reaching out for you. Got me out here in the water.
Huwag ka may index mo.
Ano yung mga inlog? Hindi, pinaparecord
And
yun.
I need your love.
Kasi gusto mo na.